Alright, here's your Unit 4 group test. Starting with number 1, we're solving the quadratic equations using any method. So you want to think about the methods that we've been using, which is completing the square, factoring, and quadratic. You want to use the most efficient way. So when looking at number 1, we think about completing the square. Well, it's good to use it when a is 1. So a is not 1. So let's try, and then you also have to think about, is b even? B is not even. So let's think about factoring. So if I was to factor this out, here's a, here's b, and here's c. For factoring, you have to take a and c, multiply it, you get 6x squared. List out your factors that give you 6 when you multiply. 6 and 1, 2 and 3. Now think about these factors. If I was to add them, would I get a negative 5? Well, maybe with the negative sign, if I was to take one of them as a negative. If I put negatives here for 6 and 1, that will not work. What about negative 2, negative 5? Well, when I multiply negative 2 and negative 3, I do get positive 6, and I do add those, and I get negative 5. So I could use a factor method. So I'm going to use the box method, where I put the first term, first box, last term, last box. Again, I did have a negative 2 and negative 3, so I'm going to go ahead and plug those into whatever box that I want. And I'm going to think vertically. What do these have a factor of in common? Well, they have a 3. They have a 3x, and then on the right, they have a factor of 2. And horizontally, these have a factor of x, and these have a factor of 1. And remember, if they're negative diagonally, they are both going to have a negative sign or subtraction sign. So when I write it into factor form, I do get 3x minus 2, and then x minus 1 is equal to 0. Now I need to solve for x, where I set each of these equal to 0. Now I need to set each one of these to 0. So I have 3x minus 2 is equal to 0, and x minus 1 is equal to 0. Where I solve for x, get everything away from the variable, I get 3x is equal to 2, divide by 3, I get x is equal to 2/3 as one solution. And then I need to solve for the next one. I add 1 to both sides, x is equal to 1. So these are my two solutions for number 1. Completing the square requires for a to be 1, and that is true, but b to be even, and b is not even, so I'm going to use quadratic formula, because factoring also wouldn't work, because if I take my a value and my c value, I get 9, but my factors would never give me, when I add them up, they would never give me negative 3. So I'm going to do quadratic formula. Again, negative b plus or minus b squared minus 4ac all over 2a, where my a value is 1, my b value is negative 3, my c value is 9. When I plug everything in, I should get negative plus or minus negative 3 squared minus 4, my a value is 1, my c value is 9. All over 2 times 1. If I simplify everything nicely, I should get 3 plus or minus the square root of negative 27 all over 2. Now remember, when you see a negative number, you know you're going to have an imaginary, so you want to pull that out automatically. So 3 plus or minus, I know I'm going to have I all over 2. Now I just need to simplify the radical of 27. When I do, I figure out 27 is composite, so I need to make it prime. In order to do that, I have 9 times 3, 3 times 3, and we know that our square root is 2, so in order to pair them up, they have to be in groups of 2. Well, I have a 3 that comes out and a 3 that stays inside. So my answer is this. Through 6, I am writing an equivalent expression and combining like terms if possible, and I want the answer to be fully simplified. So I have I radical 6 times I radical 12. So I need to multiply these. When I multiply I and I know I get I squared. And when I multiply radical 6 and radical 12, I know I get radical 72. And I know that I squared is going to give me a negative 1, because I squared is negative 1. And then radical 72, if I simplify that, because I want to simplify my radicals, I know I get 12 and 6, and I know those are still composites, so I can still break that up. So I can simplify as much as I can. And then again, my square root is 2, so in pairs of 2, there's a pair, and there's a pair. So outside is going to be 6 because I have the 3 times the 2 times our inside radical 2. So my answer is times 6 radical 2, and anything times a 1, well, that negative 1 is negative 6 radical 2. That is my answer. To do number 4, I'm going to simplify what's in the radical, where I get negative 49, and I should know that 49 is a perfect square, so I know it would give me 7, and since it's a negative inside, that tells me it's imaginary, so my answer is 7i. Again, I take my whole numbers, I get 3 times 5 is 15, and I times I is I squared, where I should know that I squared is a negative 1, so negative 1 times 15 should give me negative 15. Multiply out this binomial. I'm going to take one of them and I'm going to split it and keep one of them the same. I'm always going to choose the first one, so I'm going to do 7 times 7 minus 2i, where I'm keeping the second binomial the same, splitting up the first one, keeping that second one, 2 minus i. From here I'm going to distribute each term, so 7 times 7 is 49, minus 14i. I'm going to distribute again, where I get positive 14i, and then distribute again, where I get negative 4i squared. Now, in the middle, negative 14i plus 14i cancels out. I'm left with 49 minus 4i squared. Now, I'm not done yet because I know this i squared right here is going to be negative 1. So I get 49 minus 4 times negative 1, which when I simplify that, I get 49 plus 4, which simplifies to 53. Last question. Given the quadratic graph, write the equation in all 3 forms. So again, I want to know factored, standard, and vertex. Remember, factored form is when y is equal to a times x minus p times x minus q. Remember that p and q are your x-intercepts. And then vertex is y is equal to a times x minus h squared plus k, where this gives you your vertex, and standard is when y is equal to ax squared plus bx plus c. Alright, I'm going to start with vertex. I already labeled my vertex form and my point, some point, so I do need to know my vertex, and I need to know some point on the graph, and then I'm going to label these. I want to find, using this graph, I want to find all forms. So I'm going to start with vertex, and to go from vertex, I need to know my vertex point of my graph and some point on the graph. So my vertex is this, and my point is this. So, and we should know that my vertex form is this right here, and when I plug everything in, we know that vertex is h and k, and our point is x and y. So when I plug everything back in, we should know that our y value is 6, we're trying to find a, my x value is 1 minus, now it is a negative 1, so it's going to change it to a positive squared plus 8. When I simplify everything, I should get 4a plus 8, because 1 plus 1 is 2, 2 squared is 4a. I need to solve for a, so I'm getting everything away from a. That cancels out, I'm left with 2 equals 4a. Simplify, get everything away from that variable. A is equal to negative a half. I'm going to go straight into standard, so from vertex to standard, I'm going to multiply everything out. So my vertex form was negative a half x plus 1 squared plus 8. I'm going to multiply that binomial x plus 1 plus 8. When I multiply that binomial out, sorry, that's a 1 half. So I get x squared plus x plus 1 plus 8. Now again, multiply the binomial, you can split one of the binomials up. I get inside, when I simplify everything, I get x squared plus 2x plus 1 plus 8. Then I'm going to distribute that negative 1 over 2, or negative half, and get x squared, and then I should get negative x plus 15 over 2. That's when I add the 8 in. I don't want to skip a step, so let me go backwards. I get a negative 1 over 2 when I simplify. I still have that plus 8 outside, so now I need to combine like terms, and these are my like terms, so that's where I get that 15 over 2. And that is my standard form. So when I plug in my standard form is y is equal to negative a half x squared minus x plus 15 over 2. normally I could take my standard form and multiply it out by using the box method, but I do have fractions, so that's not really efficient. So another way of doing this is taking my x-intercepts, because we know that factor form should give us our x-intercepts, and here's my x-intercepts. Remember, x-intercepts are any points that hit the x-axis, and that is my x-axis. So my x-intercepts are -5 and 0 and 3 and 0. Now I can look at what a factor form looks like, and we should know that factor form is a times x minus p times x minus q. Now earlier we found that a was -1/2, and if I think about it, my first x value was -5, so changes the sign to +5, and x minus 3. Now it doesn't matter the order you put it, but just remember that if it's a -5 and it was a negative, you make that as a positive. So here is my factored form.